Okay guys, we're going to go ahead and talk about our foldable, the blue foldable that you guys received. Mine looks a little bit different than yours because I can't pull a foldable up on a document. So the same exact pictures are on here. We're just going to go on the front of your foldable, all the flaps. We're going to go ahead and go through those first. We're going to go through them pretty quickly because you guys are already familiar with how to find area of shapes. You've been doing it since forever. So the first two shapes here we have are obviously a rectangle and a square. And you find the area of a rectangle and a square the same way. The area for a rectangle is just length times width. And the area of a square is also length times width, but because there's not a difference between the length and the width, we call it side squared, S squared. All four of your sides on a square are the same, so side times side. And then a rectangle, the top and the bottom could be the width, and the left and the right would be the length. Okay, let's move on. The next shape we have here is a parallelogram. Okay, in a parallelogram, the formula for the area is base times height. Same thing as a rectangle. The base is obviously the bottoms that are flat. They are parallel to each other. And then the height makes a 90-degree angle. It is not the slant height. The height has to be perpendicular to the base. So base times height. Okay, our next shape is a triangle. Okay, the formula for a triangle is different than that of a rectangle. It is 1/2 base times height, or base times height divided by 2. The base of the triangle and the height of the triangle have to make a 90-degree angle or right angle. They have to be perpendicular to each other. Okay, so the slants on the side here of our triangle are not the height, because the height has to be this dotted line that is perpendicular with the base. Our fourth shape here is a trapezoid. We've just been recently talking about trapezoids in our polygon unit. There are two bases in a trapezoid. We call those B1 and B1 and B2. It does not matter which one is your B1 or your B2. The top can be the B1 or the bottom can be your B1. Doesn't matter. Again, similar to the triangle, your height has to be perpendicular to your bases. So it will be a dotted line through perpendicular to the bases. It cannot be one of the legs that is the slant height. Okay, so the formula for a trapezoid is, I'm going to need a little more space, so I'm going to write it over here. B1 plus B2. Notice I put that adding those two bases together in parentheses. You have to do that first. Times the height, and then divide it all by 2. So that is the formula for the area of a trapezoid. And our last shape is our only non-polygon here because it is a curve. This is a circle. Okay, this dotted line here goes from the center to the edge. That's called your radius. And if you doubled the radius, so all the way across through the center, that would be your diameter. Okay, so to find the circumference, which is just the distance around a circle, the circumference would just be pi times d, or pi times your diameter. And to find the area of a circle is just pi times radius squared, pi r squared. All of these formulas that we've been talking about here on the front are all found on your formula chart that you can use on any quiz or any test. Okay, we're going to go ahead and start working through some of these problems on our foldable. So go ahead and open the top flap of rectangle and square, and you'll see example 1 and 2. And we're going to go ahead and start working through these problems. Example 1 and 2 ask us to find the perimeter and the area of these two figures. The first one is a rectangle. And please notice that it gives us a conversion. 1 centimeter is 0.39 inches. And you notice we have inches on the width, but the length is in centimeters. So we want to convert centimeters to inches here. So if we have 24 centimeters and we know 1 centimeter is 0.39, we're going to take 24 and multiply that times 0.39, which will give us 9.36 inches. Okay, so that would make both of the lengths here 9.36 inches, and then the widths are 2 inches. So the perimeter is nice and easy to find. You just add up all the sides, 9.36 plus 9.36. Plus 2, and our perimeter is 22.72 inches. Okay, but it also wants us to find the area, which is just length times width. So obviously that's super easy. The length is 9.36. The width is 2. And 9.36 times 2, if I just double that, basically is 18.72 inches squared. Remember, anything that's area will be squared. So we're going to go ahead and get used to putting our units on all of our answers. In this case, it was inches for perimeter and inches squared for area. Okay, our next shape here is a square. Okay, in order to find the perimeter of this square, we need all of our sides. In order to find the area of a square, we need side times side. Right now, we're only given the diagonal of a square. What we do know about a square is that all 4 sides are the same, and that it's made up of 4 right angles that are marked for you here. So this diagonal is cutting one of the 4 right angles in half. So basically, it's making a triangle that looks like this on the top. So these 2 angles right here that are being cut in half are making 45-degree angles. And we know the diagonal is 12 square root of 2. So we have a 45, 45, 90 triangle. And we know that with 45, 45, 90 triangles that the side ratios are x, x, and x square root of 2. So since the 12 square root of 2 is directly across from the 90-degree angle, we can put 12 square root of 2 as our ratio here. So if x squared root of 2 is 12 square root of 2, that makes our x's just 12. So our side lengths across from the 45s are just 12. So that means all of our side lengths on our square are 12. So our perimeter would just be 12 plus 12 plus 12 plus 12, or 12 times 4, which is 48, and we're measuring in centimeters. And the area of a square would just be side times side, or side squared, so 12 times 12, which is 144 centimeters squared. Please make sure you are writing your units as you write your answer. Okay, we're going to go ahead and move on to finding the perimeter and area of a parallelogram. This is underneath your second flap, so go ahead and open that one up. Okay, please notice that the top up here is 22 centimeters, which also means our bottom base down here would be 22 centimeters as well. Okay, we have the height, which would allow us to find the area. However, to find the perimeter, we're going to need our legs here on the slants. In order to find that, we're going to have to use this triangle. We are given the height is 4. We have a 90-degree angle, a 30-degree angle, which means that this last angle right here would be 60. So we have a 30, 60, 90 triangle here. And we know the ratio for a 30, 60, 90 triangle sides are x, x square root of 3, and 2x. Okay, and our 4 is directly across from the 30-degree angle, so that would be our x. So our x square root of 3 would be 4 square root of 3, since our x is just 4. And our 2x would just be 8, because 2 times 4 is 8. So what we are needing this diagonal here, because we need it to find the perimeter, which is across from the 90-degree angle. So if it's across from the 90-degree angle, that makes its side length 8, which makes this length over here also 8. So now we can find the perimeter nice and easy. The distance around the whole parallelogram, 22, 22, 8, and 8. When you add all those together, you get 60, and we're measuring in centimeters, so it would be 60 centimeters. Okay, the area of a parallelogram is just base times height. It's the same as a rectangle. Your base, it doesn't matter which one you pick, 22, and your height is not 8. Your height is the one that is perpendicular to the bases. So our height is 4. So 22 times 4 is 88 centimeters squared. All area is squared. Okay, we're going to go ahead and move on to our third flap, which is triangles. We're just finding the area of these two triangles, not the perimeter. Remember, area of triangles is 1/2 base times height. So in our first triangle, our base is just 5. And our height is not 10. It has to be the perpendicular height. So our height is 9. And if you can actually put all of this in your calculator, do it at one time. So 1/2 I'm just going to use as 0.5 times 5 times 9 all on your calculator, and you get 22.5. And remember, we want to put our units. We're measuring in yards, so 22.5 yards squared since it is area. Okay, example number 5. Again, a triangle. So area is 1/2 base times height. But I'm kind of having a hard time determining which one is my base and which one is my height. So we need to take a closer look at this. Okay, remember, the base and the height have to be perpendicular to each other. Just like here, the 5 and the 9 were perpendicular. They made the right angle. So I see that these two dotted lines make a they're right angles. They make a perpendicular. They are perpendicular lines. Okay. However, these are not lines of our triangle. This is our actual triangle. So if this is perpendicular to our triangle, then we could also draw a dotted line. It's not a very good dotted line. Let me see if I can make it straighter for you guys. There's a dotted line. And that would make a 90-degree angle as well. So that's the same as this guy. So this is 18. So that gives us a better understanding of what our height is. 18 is our height, and then our base would have to be 21 because that is the perpendicular line to 18. So if our base is 21 and our height is 18, then we can just go to our calculators. 0.5 times 21 times 18, and we have 189 kilometers squared since it is area. Okay, we're going to continue on with the trapezoid now. So open up your fourth flap to the trapezoid. We just need to find the area of this trapezoid. And remember, if you look at the front of the flap, the formula for the area of a trapezoid is B1 plus B2. Your two bases added together. That's the first thing you do because they're in parentheses. Times your height divided by 2. So looks like from our picture we have both of our bases and the height. So it doesn't matter if the top one or the bottom one is your B1. It doesn't matter. Add them together. Okay, 15 plus 11 times your height of 9, and then we'll divide it by 2. So 15 plus 11 is 26. And then we can do 26 times 9, and then divide it by 2. So let's go to our calculators. 26 times 9. Notice I'm pressing enter first. I want to find what the product is. 234. Then divide it by 2. And we get 117. So our area for this trapezoid is 117 centimeters squared. Remember, centimeters squared or inches squared for area. Everything is squared. Our last problem here underneath our last flap is of a circle, and we need to find both the circumference and the area of this circle. Remember, circumference for a circle is just pi times d. An area of a circle is pi r squared. Okay, it says leave in terms of pi, which means you just leave pi being multiplied by the number, but you don't actually put it in your calculator. So it's really simple because if you look at this problem, all the way across this circle means the diameter of this circle is 4 feet. The radius would only be half of that, so 2 feet for the radius. So when we plugged it into our formula, pi times d, pi times 4 is our circumference. So really, that's all we do with it. To leave it in terms of pi, you don't put these two things in a calculator. You just leave it as 4 pi. And circumference is like perimeter of a circle. It's just the distance around, so it's 4 pi feet. So for area, we need to use the radius, pi times the radius squared. Well, the radius here is 2. So 2 squared is also 4. 2 times 2 is 4. And then times your pi. You don't put that on your calculator. You leave it in terms of pi. You just put the pi next to the number. 4 pi, and then because it's area, it is feet squared. Okay, the remaining problems that are left on your foldable are on the back of the foldable, examples 8 through 12, and we will be doing these problems tomorrow when you come to class. See you guys then.